Look at this exploded view of a standard AA battery. Every modern battery, no matter its shape, requires three strict mechanical components to function: a positive terminal, a negative terminal, and a chemical paste wedged between them. Now look at the Sanskrit text carved into these ancient palm leaves. This is the Agastya Samhita. In our modern battery, this space is occupied by an electrolytic chemical paste. While wood itself is an insulator, the formula relies on the moisture suspended within the sawdust. This liquid creates the conductive bridge required for the movement of ions between the plates. By engineering this specific liquid medium to carry a charge, the text deliberately fulfills the critical middle requirement of battery mechanics. Finally, the text instructs us to place dustelasto, a zinc plate, on top of the wet sawdust. As you can see in our model, this zinc layer acts as the negative terminal, or anode. This specific combination of copper, zinc, and moisture is exactly what you are looking at in this image of the voltaic pile. Alessandro Volta used this exact chemical foundation in the year 1800 to build what is widely recognized as the world's first battery. Now, let's test your understanding of this circuit. If we connect a wire from the zinc anode to the copper cathode, in which direction will the energy flow? I'll give you 5 seconds to think about it. Because of the chemical reaction between the metals and the electrolyte, electrons are forced to travel from the negative zinc plate down through the wire to the positive copper plate. That movement of electrons is the literal physical definition of electricity. This 2,500-year-old schematic outlines a complete active power source. To test this theory empirically, an Indian researcher named P.R. Mukherjee built this exact clay pot design in the 1990s. He followed the Sanskrit instructions to the letter and successfully generated a measurable electrical current. When hooked up to a digital voltmeter, Mukherjee's ancient replica produced an output of 1.38 volts. For context, a standard brand new AA battery produces 1.5 volts. To lock in what we've learned, here is a final translation table you can screenshot. Mrinmaya patre is the clay pot container. Tamra patre is the copper cathode. Shikigriva acts as the wet sawdust electrolyte. And dustelasto is the zinc anode. The curiosity driving this ancient inquiry into chemical reactions is a precursor to the engineering and problem-solving seen in modern aerospace facilities. From the 2,500-year-old clay pot to the modern voltmeters of today, the mechanical logic remains consistent: a precisely engineered chemical source capable of powering a circuit.